This is part 3 of reviewing Unit 7 with the graphing. So we're just going over 7.2 and 7.3. We have to have an understanding of the parent functions, the parent graphs, and kind of what it all means. Once you have that, we're just going to be working on some examples. So I have 6 more examples total. So I'm going to kind of look at the information on these ones all at the same time. So, and then we'll kind of graph them individually. But the amplitude on all of these this one's a 1, and then this one's a 2. So absolute value of 1, absolute value of 1, and absolute value of 2. And then we'll look at a phase shift. Technically, you could be looking at these in any order. I just have this order because I don't know. So that's where we set the insides equal to 0. So when 2x is equal to 0, x equals 0. So I'm not moving it left or right anything. Again, when 1/2 x equals 0, x equals 0, I'm not moving left or right. On this one, I add pi thirds to both sides and I get pi thirds. So it does have a phase shift on this one. We're moving right pi thirds. Mean line. So again, there's nothing here, but this one has a 1. So 0, my baby learned how to make noises. 1. Okay, and then the period, that's where you take 2 pi, always 2 pi, and divide it by the b value. Now that's the number that's in front of x. So I'm looking at 2. Here I'm looking at 1/2. Here I'm just looking at 1. So what is 2 pi divided by 2? Pi. This one I'm dividing by a fraction, so I need to multiply by the reciprocal. So I get 4 pi, and this one's just 2 pi. Okay, and then we're going to look at the x scale, and that's going to tell us kind of how far we need to go in an x direction to move up or down. So x scale is the period divided by 4. So the period divided by 4. So this one's just pi fourths, this one turns into pi, and this one turns into pi halves. So that's kind of how I need to scale my x-axis. This one's going to be a little complicated because we have an x scale of pi halves and a phase shift of pi thirds, so we're going to want to get a common denominator on that one, but we'll do that when we get there. So with this one, I also want to talk about the parent functions. Cosine starts at the top and does that. Sine starts in the middle and then does the pattern. So when I draw the graph of this one, remember I want a period of pi. I'm going to still graph to 2 pi, so you can kind of see. So those are my pi half marks. We also need a scale of pi fourths. So I'm going to make marks in between these to signify pi fourths. So pi halves, pi fourths. Oh, and then 1 and -1. So we don't have a phase shift. The mean line is 0. So that's going to be my middle. The amplitude is 1, so 1 above and 1 below. That's my max and min. The period, instead of doing this whole thing, switch the cap colors. Instead of doing this whole thing in 2 pi, I want it to take pi. So I still am going to start at the top, but now I need to end at pi instead of 2 pi. So there's my green marker. I thought I had another green marker. Oh, there it is. So we're going to start at the top because it's cosine. And then we're going to step every pi fourths. So remember, that's this mark right here. And then I'm going to keep stepping. And I complete 1 cycle in pi, because that's the period. So if I keep going with this, I'm still stepping every pi fourths. So that would be the graph. So if I did draw just cosine normally, it would start at the top, but it would be stepping by pi halves. So it would do this. So what happened was this got squished in. So if you imagine kind of like a string or a pipe cleaner or a hair tie, I'll pull my hair tie out. There's hair on it. It's a hair tie. So essentially what happened was this got pushed. So if this is my function, it got pushed in. It just didn't make it taller. It just got pushed in. So that's kind of how the period change affects it. So now we'll do when the period changes to be this. This is actually going to stretch it out more because now it needs more space to complete 1 cycle. So again, the only thing that changed on this one was the period and how it's stepping. So this is that middle. My maximum is going to be 1. And minimum is going to be -1. No phase shift. So sine starts in the middle. And I'm stepping every pi. So that's where I'm going to switch. Switch, switch, switch. So if I continued the pattern going backwards, switch, like that. And so if I draw the function just normal to kind of compare, that's when it would normally be stepping by pi halves. That would be 1 period. So what happened was it got stretched out. To kind of show you on the graphing calculator, we'll stick with just sine, but I'll do sine of, we'll do 2x first. So that's my normal function. So it just kind of has more, it gets squished in, it has more peaks and valleys over the same amount of x distance. So then if I change it to be 0.5, so 1/2, again, that's my normal function. And now it's more stretched out. So that's all that it's doing. Okay, and then I want to get through one more example in this video. So with this one, we have a lot going on this one. Okay, so the mean line gets moved up 1. So this is my new middle. And then I want 2 above that for the amplitude. So 1, 2, 3. And 2 below the mean line. So 0, -1. And then, like I said before, we are going to want to put things with a common denominator. So if I have pi thirds and pi halves, I'm going to turn those into pi 6, or something over 6. So 2 pi 6 and 3 pi 6. I should have used brown with that one, but that's okay. So what we're going to do is I want pi 6 marks. So I'm still going to do, okay, this is pi, 2 pi. This is pi, 3 pi halves, pi halves. But I want sixths. So what I'm going to need to do is make 2 lines between those, so that I have 6 lines total. 1, 2, 3, 4, 5, 6. 6 pi 6. So we'll just kind of stick with that. So cosine starts at the top, but this one we are moving to the right 2 pi 6. So instead of here, we have to go two marks. And then we're stepping every 3 pi 6. So I need to go 3 marks to move. Oops, here's the other green one. So if that's where we're at now, I have to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, and then I'm off the graph. So I'm going to go backwards. 1, 2, 3, 1, 2, 3. We'll just put it there. So that's the graph now. So it's a little more difficult. That's probably the most difficult concept, is when you have something when you're working with sixths. So pi thirds kind of always throws it for a loop. I'm going to talk about domain and range real fast on all of them. Domain is all real numbers. Range, that's where we're going to look at the maximum and minimum. On this one, it was -1 to 1, -1 to 1. This one, because it was shifted up 1 and had an amplitude of 2, it's actually -1 to 3. Okay, and then I will do, I think of 3 more examples I will do on the next video.